Hey, what's going on, friends? Welcome back to another tutorial. We've been speaking about multiplayer for quite a while. Now it's time to actually implement some of that. Today we are going to be having a look at hosting a server on your editor, on your Unity editor, and then running it in either a standalone client or a WebGL client. So let's have a look here on the right hand side, and I will boot the server scene. The reason I like to boot this one in the inspector is so I can have a console at the bottom here. Now if I reload this page, you'll see that we have a connection on the server. In a second, of course. Connection from 1 being this connection ID, through the channel 0. And we can boot another instance, and then we're gonna have a connection from 2. So it is only 2 scripts, it's only 2 scenes, but those are quite complicated to explain, so that's why it actually can take a little while just to get in the mood for it. Now remember that we're doing this to learn how to make multiplayer work. We're doing this to understand how to create a game around this and how to use WebGL in the mix. Now one more thing is, in the end, you will not be able to run a server on WebGL. You're gonna have to run a server on a standalone machine, so something like this machine right here or the editor, and then people can connect through WebGL. But the machine that contains a server has to be an actual machine, not a web server. And yeah, so that's about it. Let's get right into the game. Hello, I hope you guys are doing good. I am doing amazing this morning, and we're gonna go into something that is really interesting. It's actually a browser-based game, a multiplayer browser-based game using WebGL in Unity, and I hope you're having a nice little glance at my desktop. That's not part of it. So here's how we're going to be working with this video. It's quite simple. I have another project called Net. This is the one I'm working on all the time to get my multiplayer things right, and I will actually be I'll be running with 2 projects open, one in my main screen, so this is a project we'll be working on, and also one on my off screen, so I have a little help and we can go through implementing this thing fairly fast. So we're gonna do that super fast. I'll be explaining it as I always do, but of course it's not gonna be the in-depth explanation. So my thinking behind this video is that we're gonna go into something really complicated, multiplayer that is, and we'll try and give you the bits by bits of what we do while we implement it this way. If you guys are interested in knowing more, you know exactly where to look for, or you can go back on the lines and actually Google specific thing about those, because unfortunately I cannot give you like a full multiplayer explanation right here. I think it's much easier for you to just implement it on your own, experiment it, you see where the bottlenecks are, you see where the problems are, and then you go and you try to refine them and make it better. So I'm gonna stop talking right now. We'll switch the scene into the recording mode, and let's actually get started. So as you can see, I have a brand new project right here. There's only 2 folders in here, one called client and one called server. The goal of this project is that we build a server, we run it on our local machine, so right here, and then we open multiple tabs in our browser and we play our game, and they're all connected to the central server. The first thing I'd like to tackle is actually the server. So I'm gonna go ahead, open up Visual Studio on my other project, and move it to the other screen. Now I will create a server script. You can just call it server for now. In my other project, I call it master server, because in the end, we want to have something that has multiple server, and one of them is going to be the master of all the little servers beneath. But for our example, we'll keep it simple. We'll call it server. Okay, let's actually open this up in Visual Studio as well. And I'll be having 2 instances, one on my left and one in front of us right now. Okay. So, let's clean this up. And now, at the beginning, we are going to define a couple of things that are going to be specific to our server. I like to call those the constant. Now, all those constant are things that you'll be able to define on your own depending on your server need or on your game need. So, I'll start with some private cons. The first one, a int called max connection. So, how many people can connect to your server? I'll put that on a default of 100, of course. If you try to create a bigger server, or in my case, if I was trying to create a master server that has only other server connecting to it, then I'll put the exact number of servers so I know nobody else try to impersonate one of my smaller server and actually hijack one of the spot. But you know, that's a little bit complicated for now. Let's just assume that's how many people you can actually have playing your game. Next up, private string, the server IP. So this is not really required in the server. I like to put it anyway, because the server doesn't really need to know its IP, or we can get it through code. But in this case, we'll run everything on localhost. As I mentioned in the intro, eventually we'll publish it somewhere else, but at the beginning, you always want to be testing locally. Next up, which port are we going to be using? And let me just make sure that I put some cons in here. Oops. And the port, in my case, could be, let's do something like 8999. Just make sure it's something that nobody else uses. Next up, we have the web port. So I didn't mention that. What I'm going to be doing here is that we'll have two kind of connections. So you can connect with a client. So somebody playing on a standalone game, a standalone version of your game could connect to your server, but somebody on the web could also connect. They're going to be using two different ports though. So web port, the one we'll be mainly using, I'll put that on 8998. And finally, you need to have a buffer size for the communication, and that is your packet size. We'll come back on that because that's a little bit complicated to explain right here, since we have not really implemented just yet. So buffer size, default that on 1024. Next up, we'll need some channels. Now, you probably heard about UDP or TCP or reliable connection and unreliable messages. Sorry, not connection, messages. So reliable messages and unreliable messages. We'll start by declaring two of those, one called reliable channel, and you'll take the ID, and then another one. I put them protected here because I just copy paste, but basically since we don't have any inheritance, let's put that on private. This one is the unreliable channel ID. So if I want to go quickly through this, there is two type of, well, first off, UNet always works on UDP. So if you know a little bit about UDP and TCP, UNet is all about UDP. And to make sure some of the transaction always get confirmed or some of the messages always get received, they create some kind of protocol that make sure your messages are received. So there is kind of two protocol if we're outside of the UNet scope. One is called UDP, which means you're gonna send messages and the server is gonna receive them, might receive them, or it might not receive them. So you want to be putting any communication that is not really required in your game on that channel. So say you're updating the movement of your player. This is really good for updating movement of other players. It's not a big deal if you skip a frame or two. So if for about 2 or 3 seconds one of your player disconnects, it's not a big deal if he does not update the position of all the other players in the map around him for that 2 or 3 seconds. You're going to be seeing a desync, and that's his fault for not having a good connection, or that's your fault for being under a big load. And that can be, you know, that can be skipped. It's not a big deal, it can be skipped. Now, there is one called the reliable channel, or if you're outside of that scope and you just want to be using other protocols like TCP, those are messages that have to be received, and they have to be received in the right order. So in that case, if your player does a purchase, so if you purchase an item from a store with in-game currency or real money, so if he buys an item, you want to have the other message that says, well, here is your item. So if you send money, you want to receive a good. Now, if you send money and then the receive a good package is being lost, then you still sent your money. That one has been approved, but then you lost your connection and you didn't receive the item, or a server didn't send the item. That is not good. So that we're going to make sure it doesn't happen. This is why we put that information, that package that we're going to be sending from the server to the player, or the player to the server, on a reliable channel. This way the message isn't lost and it arrives in the good order. So just imagine this as some kind of tunnels, and when we want to send a message to the server, we either send it through a tunnel that has holes in it, and usually, like most of the time, it doesn't, like the message doesn't slip through those holes, but sometimes it does. So can we afford to lose that message? In that case, yep, let's use the unreliable because it's way faster. It doesn't put your server under a load. Or should we put it in the reliable channel, the reliable tube? And in that case, the message always get received in the right order, but it's much slower and might actually put your server under very big load super fast. Alright, so now we have all of these fields. There is a lot more left to put in there. There's a bunch of logic field that only applies to this script. But before I go into those, I'm actually going to start coding the initiate function. So the how's it called? Initialization function and the start function, you could call it. So we're going to create those fields when we need them. So let's go ahead and do a private void start. So we're going to be using mono behavior in that case. I'm going to remove it by the end of the tutorial. I don't like to have my server started like as soon as I open the game or open the scene. So eventually we'll put that on a button. So we'll put a start server and stop server on buttons. But for now, let's put it on a start. So it starts like this. You need to have a global config. And this one doesn't exist at first. So you have to make sure you're using Unity Engine.networking. So at the top right here, make sure you type that in. You have that namespace. This is an object. We'll call it config, and we'll just create a new default object for the global config. Now in here, you can modify a couple of things. Not that we're going to be doing that, but if you want to actually modify things like you see here, maximum amount of hosts, maximum packet size. This is basically our buffer size. And all of this can be modified. I'm going to invite you to actually look into every single one of these on the Unity documentation if you want to go a little bit further with the configs. But with the default settings, we are okay to keep on going. Most of our, actually all of our communication is done over a class called Network Transport. This is also part of Unity Engine.networking, and we have to make sure we initialize it like this. Now when you initialize, you can just initialize it this way without any parameter, or you can send in the global config you created. In this case, I will add it. Just to be fully transparent, it's the same thing as doing this. The config doesn't have any effect, because if we do a initialize on network transport without the config, it's gonna create a new global config with no parameter, just like we did. The reason I let it in here is so in case you want to change your config, you can do so right here. So this way, this would work. Okay, right. So we just initialize our network transport, and do remember that this is going to be ran on a machine and not in a browser. Next step is to create some kind of topology. So host topology. And we can do this by starting again with a config object. This one is called connection config. I like to short it to CC. That's also what people do in the documentation. We will default the connection config to a new connection config object, just like we did before. So we're going to be using the default settings. Now the reason we're using this is so we can actually add channel to this connection config. So we're going to add things to it just like we saw earlier. But this time, the function we'll be using is add channel. Now add channel, we want to go ahead and add a channel that is reliable in our case, and one that is unreliable. So those are the two tubes I mentioned before. And as you can see, there's a couple of other things. So unreliable, fragmented, I invite you to read again what kind of channel you could create in that case. Now the add channel also returns a byte. So I actually put it under int, but we could put that under bytes. And that's a identifier for the channel we've created. So we could actually do that right here. I'm going to leave them on int because on my other example I had them on int. And here we go. So unreliable channel is going to be equal to the unreliable channel ID. Alright, so we have those configuration. Now we're ready to create our topology. So host topology, topo, new host topology, and then ask us, so what are the CC, the connection config, and also the max default connection. This is something we have at the top in our constant. And just like this, we managed to create some kind of map for this script to know exactly how our network is configured, and that has to be reflected on both ends. So the client needs to have the exact same thing, and the server needs to have the exact same map, so they can both follow the same protocol when they're connecting and exchanging information. Okay, that was my phone, sorry about that. Next up, we're going to be adding host. What do I mean by that? We're going to be adding hosts, so people that can receive information through a specific port. As we mentioned before, we have two things here. We have a server port and also a web port. So those are the same thing. They're both server ports. Actually, this one could be called server web port for incoming web connection. And those are two different hosts. So they're going to be two entities getting information. And we can start them both over here, but they have to be on different port. Now, we'd like to know exactly, we'd like to put a ID on those hosts. So this way, if we want to like do an action on a host, and we know which one to use based off a ID. So I just add it down here. I'll call it host private int. So let's call it host ID, and then private int web host ID. And let's add them. It's fairly simple. We have to create a host ID. Actually, we have to use our host ID, and then do a network transport again, add host. And then it asks us for the topology, something we just created a second ago. Then we of course want to send the port. In this case, this is the one that is not on the web. So this is the host that receives connection from other standalone client. So we'll be using the port, the server port in this case. And then there is also one more parameter you can send it. In this case, it's called a string IP. It's an address you can bind your host to. So in our case, we're going to be using our own address depending on what is our own address. So right now we're on localhost. It's going to be 127.0.0.1, but it depends on where we eventually publish it. So once we publish it on the other machine that is not our machine, so something that's on the web and ready to take in incoming connection from somewhere else, in case we want to host a Amazon machine, it's going to be a different IP. But you can just leave it like this, and it's actually gonna get that IP if you don't put anything, or you can also put null if you want. In my case, I'll leave it like this. Now let's copy this line and change this for the people that connects via web. So WebGL, web host ID is gonna be equal to add host, but it's gonna be add WebSocket host. So instead of using the typical normal socket you'll be using depending on which OS you have, so you might be using WinSocket if you're in Windows, and something else if you're on Mac. I'm not quite sure about that one, but Unity takes care of all of that in the background, so we don't know. But if you're on WebGL, you're going to be using WebSocket because that's the only thing that can go through the browser. So we're going to be adding a WebSocket host, and in that case, again, same topology, but instead of using the server port, we'll be using the web server port, so server web port. So isn't that amazing? We already have something that works. We can put our machine out there in the wild and make sure the ports are forwarded, and then it's going to take connection. It's going to be able to bind like a connection to a port. However, what happens when somebody connects? We still have nothing, no event, no message being sent, and that's the second part. So now we completed the whole protocol part where people can connect. Now we have to make sure that something happens when they connect. So let's go right beneath it, and we're going to keep on going, and this is how we actually do it here. So we're going to be doing that in a update. So every single frame in the Unity world will be having a look at if somebody connect, if somebody sent us a message, if somebody did something with their connection with us. So let's go ahead and actually check something at first. So in case we haven't started yet, or in case this whole action here is not completed just yet, I'm going to make sure that I create a boolean called isInit, so isInitialize. At first it's going to be false, and as soon as this is completed, it's going to be true. Now in this case, it's actually running the start, so you know it's going to be completed before it hits the update, since the start is always ran before the update, else you could put that on awake if you wanted to. But like I mentioned a little bit earlier, eventually this whole process is not going to be in the start. It's going to be a public function, say bound to a connection button or a start server button. When that happens, the update is going to be ran, and the server might not be live yet, which means that's going to cause an error. So I'll make sure to run this only if isInitialize is equal to true. And to do that, I'll check if it's not initialized. Let's return right away. Okay, so what happens in here? Well, every time we have a message, we have to get information from that message. So this is kind of a packet that is being sent to you. The client sends you a whole package with information on it, and you have to decode it to get the information out. There is a couple of fields we'll be using here, one called outHostID, another one called outConnectionID, and outChannelID. I put them all on the same line since that's going to be a little bit too many lines for the same kind of information. And I'm also going to create another one called received size, and finally one called byte error. Okay, so what are these? Once you receive a package, your package is going to have a couple of things in the header, in the signature, and those are going to be first, which host site are you pinging? So are you pinging from the web, or are you pinging from a client, a standalone client? What is your connection ID? So once you connect to a server, you are assigned a connection ID. So if I'm the first person that connects to this server, I'm going to be connection ID 1. If somebody else connects while I'm there, he's going to be connection ID 2. If I log out and a third person connects, he might actually take my spot and become connection 1. So this is important to know because you can bind certain IP on connection ID, or you can bind certain user on connection ID. And then finally, which channel is he using? So when he sent our package, did he use the tunnel with holes? So is that information we can afford to lose, or is that information we have to process absolutely? Then how big is the message we receive? And finally, if there's an error, we will actually put it in that byte. Alright, so we lay down all the memory field that we'll be using, all the fields we're going to be using for that message we receive. Now it's time to actually receive that message. So let's go ahead and, not a native class attribute, let's do a network transport. I keep mistyping this. Okay, network transport dot receive. And this is where you receive your message. Now, as you can see, we have a bunch of parameters. Those are all the field we created. So we have to say out. Well, this is our out host ID. This is our connection ID. So connection ID, there we go. We have the buffer here, which I don't think we defined just yet. So let's put that on nothing for now. We'll come back really quickly. Whoops, I missed the channel ID. Sorry about the wrong order. This is the buffer. We want to leave that empty for now. And finally, the buffer size is, again, something we'll leave empty because we don't have it just yet. And finally, out received size and out error. Okay, so this is the function we'll be using to receive our message. There is two missing fields. One of them is called the buffer, and the other one is the buffer length. And we'll actually go at the top and declare that in our logic because this is part of the logic, and I'll explain you what is the buffer in that case. So private byte array buffer, and we'll instantiate it right there with a new byte array of buffer size. Remember, this is a constant we've put at the top. So you cannot send a message that is bigger than that unless you fragment it, and we will eventually be on the fragmenting topic, but not today. So today the limitation is going to be messages can't be bigger than 1024 byte, which is plenty of space, to be honest. That's actually quite a big buffer. And also do realize that every time you increase, say you want to say, well, my game's going to take bigger information, say 2048, well, you're also increasing the time it takes to send one message from either way. So I'd like you to see this as, this is your box, right? You have a box you have to ship through UPS or FedEx, and you can fit whatever you want as long as it fits within that box. But every time you're shipping, even though it's a really small item and it only takes, say, 1/20th of the box, you're still sending the whole box in the tunnel. So box is always going to be the same size. Now it would be smart to fragment your data in case you have like many things to send. It would be smart to put them all in the same box, but this is a little bit complicated right now. So for today, just tell yourself that every time we want to send information, even though it's only a small int or it's a long text with a lot of character in it, the maximum size is always going to be 1024 bytes. Okay, let's go back here. Now we have our buffer. We can say buffer in here, and the buffer length is simply buffer.length. Alright, so receive also sends you a network event type, which is something we have to store because there's there's actually 4 different events that can happen with your package. This is something being sent by the network transport. So let me actually just put that in front of it. So network event type, we'll call it E, and it's going to be equal to the receive return. Now, one of the network event type is nothing. So in case nothing happens, because we're checking this every frame, right? So it doesn't mean that the server is going to receive message every single frame, which means that you can have empty, like you can have something null come out of this. And if that's the case, then network event type is going to be called nothing. So let's check this, right? So if E is not equal to network event type dot nothing, if it's not equal to nothing, then let's go ahead and keep on going. Or you could go ahead, you could go and undo the other thing. So you could say if it's equal to nothing, we'll put a return and we won't go any further, and we'll say there's no message here. Actually, don't say there's no message here because it's gonna be called quite often. So I'll just put a comment here. There is no message. Let's stop here. And then next frame happens and this whole loop is being played over and over again as long as the server is up. Okay, so let's do a switch. In case there was something, we're going to do a switch on that network event type. And like I told you, there is 4 different events we have to look for. The first one is a connection event. So that's the initial package, that's the initial message being sent. We'll say if it is connected event, then in that case we want to do a couple of things in here. And let's also make sure we have a break. And there we go. So what is the problem? There's no problem anymore. Okay. I'm actually going to skip putting stuff in here just yet. We're going to go ahead and keep on creating those events. So I told you there is 4 of them. One is the disconnected event. So same thing, but that's when you disconnect. Then there is the data event. That's the one we'll be using all the time. Another one called broadcast event. And if you want to be safe, you can also put the nothing event. I didn't count that one as one, simply because it's just nothing, right? So in case it's nothing, return, and that'll be it. Now there is no other network event type, so it's your choice to put the default or not. But you know, like there should not be anything else. That's what I put in my in my other code, but you don't need that, because it just can't happen basically. And as I am scrolling up, I just realized that I did a little typo here. I put twice the channel ID. I want to put the host ID in here. My bad about this. This is kind of error I do the most. Okay, so what happens when somebody connects, and why is it different from data event? Let me explain to you what is going on here. So when somebody connects, they still don't have a connection ID. They still don't have all the information to be connected to the server. So it's the initial call, and it's a little bit hard to have the full context around the user until they connect. So this is what it's actually being used for. And disconnect event is the same way. So you know that when you receive a message, a network event type of these 2 types here, then it's a special step. It's not just like your player is sending data in the game to be processed. It's actually a different kind of event. So they split it this way, and it's actually a good thing, because here you'll be able to say something, well, this is where we create our user, and this is where we destroy it. Speaking of which, you need to keep the information of your user. You need to actually keep track of who is who, because in case player 1 sends information to player 2, you need to be using connection ID of player 1, and you need to send it to connection ID of player 2, because your server doesn't know about these things just yet. This is of course something we'll be doing quite soon, but I want us to try this out at first. So we'll start by just putting debug.logs, and we'll say when somebody connects, do something like this. So connection from, and then remember we have information because we receive everything through the receive function. So we're going to say connection from, and then you could say out connection ID. So connection from 1, connection from 2, connection from 3, depending on which is the connection ID assigned to the player that just connected right now. Now of course, this is also why we need to have a definition for a connection and players. So you need to create a player object that's going to be bound to a connection. This way, you know, you have more information than just a number in the end. but this is how we're going to start doing it. So connection from 1 through the channel out channel ID. So you're going to be able to know what is the connection ID, and also which channel is he speaking through. Is he speaking through the reliable or the unreliable channel? And that's all we're going to be putting on here. I'm going to be putting the same exact thing in the disconnection event. So disconnection through, actually we don't need a channel in this case, or actually we could keep the channel. Alright, so a lot of information just came in. We are going to test this out, so let's go ahead and save it. I'm going to go in my project and put a server object just anywhere really. It doesn't really matter. We're going to call this server, put the server script on it, and everything else should be technically completed. So if I go ahead, I'm going to save this scene as server as well, or server scene to be a little bit more specific. And if we run this, technically we should be able to connect with our browser once we have a client built. So let's go ahead and run this, see if there's any error, just like standard check. Nothing happens. That's fairly normal because nobody ever connects. But there's no network transport error. We ran through the start without any issues. Now it is time to create a client. Client is the exact same way. We'll try to go super fast over it. I know we have been taking a lot of time, so we'll actually go fairly fast because it's the same exact thing. There is only one difference. Instead of creating hosts, actually you still create a host, but instead of ending there with the start, you have one more function that is called connect, and then it connects through either the web socket or the regular socket. So let's go ahead. We're going to do that fairly quick, like I mentioned. We are going to create a client script, and we'll be copying a lot of things that we have from server. So open both and clean this one up. So make sure we remove everything in between. We're going to go back in our server script, make sure we include the Unity Engine networking. Now back in our server, I'm going to copy all of this, including the web host ID, all these three little sections we have for the fields, and put that directly in our client. So let's have a look quickly if everything matches. Max connection, that's right. The reason we need this is simply so we can match the exact same topology as our host has, and that's just required. That's something you need to do. So server IP still on localhost, server port still the same, everything is the same, buffer size is the same. We have the two channels, and I'm going to repeat it once more. The reason we have this information duplicated on both sides is so we can create the same server map, server kind of infrastructure. And okay, now the only difference here is under host, we're going to have only one host. So we're not opening our client for connection. We are only connecting to the host. So we only need one host, and then we're going to need a connection ID as well. So I'm going to be swapping these around. And just tell yourself that you're always going to have, you're going to be having a connection with only one person. And that person is going to do the link in between you and all the other players. This is not a peer-to-peer game. As much as I hate peer-to-peer. Okay, now under logic, we are going to need a couple of things. So for now, I'll just put a private bool is connected. This is the same as initialize from the server. So same thing as is initialize. We're also going to need a buffer as well. I forgot about that. Let's go ahead and create it. And here it is. Now, as far as the start goes, we are also going to be copying this over. So let's go and copy this. But we're going to change a couple of things in here. So this stays the same. The connection config, we create the same channel, we create the same host topology. This always stays the same. And now this is where it starts to get messy. So when you add a host, actually, it's not adding host, it's actually connecting to host. And here is what we do. So we have to add it again. So right, network transport, network transport, add host at the same topology, and then 0 in that case. Why exactly do we do this? Because we need to have a definition of what we're going to be connecting to, and that definition carries the topology we've created. So we have the same network map. Now I just put 0 here, you could put null, it doesn't really matter because you're not accepting connection, you're not defining a server IP for yourself. And this is where it gets cool. So assuming that we are connecting through a client. Let's start with a client. Actually, I hate to call it client. Standalone client. So say we're connecting from another Unity game or another build. We're gonna say, network transport connect, and that's the function you need to remember. Where do we connect to? Like, what's the host ID? The host ID in this case is going to be either 0, or we could just use host ID. That's also going to be 0 in that case, because we only have one, right? And then the address, in this case, the server IP. The port, that's because we are on the standalone client, that's the server port. Finally, the exception connection ID. This one, I'm going to be super honest with you, I think it's new because I didn't see it before, so I'll just put that on 0 or null. And the out byte error is out error. I don't think we added that just yet. Let's go ahead and create a new byte under logic, so private byte error. So we can use it here in case there's something that goes wrong. Okay, so that works super good if you are on a standalone client. But what if we are on OpenGL? That's the whole goal of this tutorial. What if we are on OpenGL? This is where it changes. So I'm going to do a preprocessor thing at the top here. So we'll say if Unity WebGL, then we're going to do something else. We're going to be doing what we just did right here. And also do a NIF down there. So that's a standalone client, and at the top here we'll put WebGL client. Oh, and also something I forgot, I'm sorry about that. The connect also returns a int, and that's your connection ID. So let's make sure we match that as well. You need to know your connection ID because the server knows it. Now, I'm going to take this line just down here, so I have IntelliSense, but I'll bring it back into the WebGL in a second. So connection ID is going to be equal to the same exact thing. This time we're trying to connect through WebGL. So same call, you do a connect, and then host ID if you want. The port in this case is going to be the master, not master, the web server port, server web port. Oh, am I in the wrong? Sorry, I am in the wrong. It's the server IP first. Or you could just copy the line beneath it, to be honest. That would be much faster. Connection ID is 0, and then out error. Same exact line, but we have a preprocessor call that checks whether we are in WebGL or not. And we're also changing the port. So remember, this is 8999 and this is 8998. And here we go. So we have the client trying to connect as soon as the start is open. So we're going to do something right here. We're going to go test this out to a very minimal extent. Like, according to what we did, the only thing we can get out of this is basically this debug.log over here. So connection from through the channel. And this is the only thing we can have at the moment because we don't have any communication from the client. So we're going to go ahead and test this out to a very minimum extent. This way we can know whether or not it works, whether or not there is a connection between the server and the client. So let's go back and create a client scene. I'm going to have to split these two scenes, of course, because like at the moment there is no way for the client to be a server as well. Eventually there will be. Spoiler alert. I called it client server. Okay, client scene. Alright, so now to test this, we are going to be doing the following, and I need you to understand exactly what we'll be doing so you understand why it works, and also this is not something we'll be using in the future. It's not efficient at all to test the way we're going to be testing right now, but we don't have any structure around what we're going to be doing right now, so we still want to know if it works at this very step. So we're going to go under the build settings. Make sure that the client is inside a scene to build. So when you actually build this as a standalone, which we are going to do right now, when it starts, the client is going to start because you're going to boot in the client scene, and the client scene has the client game object, and the client game object has the client script on it, and that one has a start. Okay, so if we just boot it right now, nothing's going to happen because you're not going to be connecting to anything. So you're basically not going to be connecting to any hosts anywhere, even though we said it's going to be on 127.0.0.1, which means we're testing this locally. Now, what we're going to do is I'm going to move this on the side for now. I'm going to open up the server scene, and remember we have some debug.log in the server scene, so that's going to help us understand what's going on. And just to make sure I have one more debug, I'll go in the server script and just say something like debug.log starting server. Right. Now I'm going to press play on this and leave this up. And something really important that I have not done just yet, and I almost forgot about it, we have to go under File, Build Settings, Player Settings, and this has to run in the background. So if you're not in focus with your server, he still needs to receive the messages, and that's really important. So we are running in background, make sure that's the case. And we should actually build the client again with this. Sorry about this, I totally forgot about doing this. Okay, right, so this is completed. This is the client. We are not going to start it just yet. We have to make sure our server is up first. And the starting server call is there. Now I'm going to go ahead. This is my client being run. I'll put that on the smallest, make sure it's on the windowed, press play, and hopefully we'll have a connection down here. And as you can see, connection from 1, which is connection ID of this guy, through the channel 0. And if we close it, wait a little bit, disconnection from 1 through the channel 0. So, and this is amazing, guys. This is amazing because we are actually testing this with the engine itself. We have the engine build, we have the Unity editor build, and we have the console.log happening. So that's our server right here. Now, something that some of you are going to think right now is, well, it kind of sucks. It's kind of not efficient to have a server running in Unity because you have to render this useless piece of graphic, this stupid skybox. And I'm going to be in total, well, honesty with you, is yeah, it does suck. It does suck. You're actually using some of your server power to render this useless screen. But that can lead to some interesting options. You could actually lay down, like for your server only, you could have like a map, an overview of the map with all your players in it. And you can actually have a look at that in your server screen. So that could be nice. That could be fun to look at. But it could also be used in other contexts, such as the client now becomes a server, so the client now hosts, and in that case you would be the server and you would be the client at the same time. So you're creating a game and then people can join you. So it's another use you can do with this. Now if you're really worried that it's really inefficient and you want to have the most efficient server alive, what you can do is wait wait, because Unity does plan to release their network transport as a library that you'll be able to use without the graphical output. It has been scheduled for late 2017, but it's been delayed. So we're expecting to have it at least this year. So if you're making a real multiplayer game, a real big project, then of course you're gonna have it soon. And if you can still start developing now, and it's gonna take a while if it's a serious game, right? So you can start developing now and eventually switch that over to the library. It's gonna be a little bit of work, of course. It's not gonna be as clean as if you started from the get-go using that library. Now, next step, we're gonna test this again, but with multiple client. Again, super simple. I'm gonna open my project folder. This is where I have my client. I am still running this editor in the background. The server is still running in the background, and I'll be opening 1 window, 2 window, 3 window. Let's see what happens down here. Connection from 1, 2, and 3. Let's close connection 2. Disconnection from 2 through the channel 0. Let's close 3. Disconnection from 3 through the channel 0. So as you can see, it matches exactly what we want, right? And finally, one last test we'll be doing for today, and I just want to make sure that you understand that this is the first episode. We're going to be going a little bit further with this every time. I just don't want this to be 1 hour each, you know. So next step we're going to be doing is testing this out through WebGL. Like I said, we want to do this for WebGL in the end. You want to have your server right here where it's at right now. It could be running in the editor. Now, I don't really recommend that, but you know, once you have your final build, you can put your server scene in the client, server scene in the build settings, and you know, start it there. Have your client running on a Windows machine, on a Mac machine, Linux machine, any kind of machine you want, and people are going to be connecting through that. Now, what we're going to be doing right now is this thing. We're going to go on the WebGL, switch a platform, and I'm actually going to cut this because it takes a while to create a build for me, a WebGL build, but you're going to go ahead and do a build and run I'll call this WebGL client, or it asks you to select a folder. Okay, let's create a new folder, build folder, and I'll call this WebGL client. Does not exist. Okay, then let's just use this build folder then. Right, so I'll be right back in a second. I'm gonna wait until this is completed. Okay, so we are back. It took a little while to build. Let's go ahead and run this, right? So we're gonna go under the server scene. Here it is. And my WebGL build, which started automatically, so it launched this thing on my Chrome by itself. And here it is. I'm going to refresh this and see what happens. So using our pre-compiled little call at the beginning, it should actually define that it is from WebGL, and here it is. So something really interesting to look at the moment is if we launch other tabs, you're going to see this information coming as well. Same thing as before, so connection from 2 through channel 0, and then what is really interesting is that in a WebGL build, the web socket is actually constantly sending information, so you're always sending information when you're connected to this, all the time. Now, exactly what's inside of it, I don't know at the moment, so we're gonna have a look, right? So we receive a buffer with data, like all the time, once we're connected, and that's the different thing from regular standalone socket. So what I'll be doing right here is I'll try to remember what's the call I have to do so I can transfer this into a string so we know what's inside of it, because I'm curious. Okay, so I have it right here. We have to do a system.text.encoding, oops, not encoder, encoding.u2f8 or ASCII or whatever you want to use. You do a get string and then you send in your byte array, in this case the buffer. This way we'll be able to know what's inside that mysterious, really mysterious chunk of data. So I'm gonna go ahead and close like all my other tabs but one. Let's make sure you keep one because it has a different port every time. You don't want to close this. And I'm gonna go ahead and run the server again and connect to it by doing a refresh. It's gonna connect, and in our debug.log we'll be able to see what's inside of that message it keeps sending. So it says null, or ULL in this case, because we're missing something. Obviously there's a little problem with the buffer, but as you can see, there is data being sent, and we're actually connected through WebGL. So this is actually where we'll be ending today, guys. Thank you so much for watching. If you enjoyed this kind of video, or you enjoy me talking about WebGL and also multiplayer stuff in general, I've told you already that this is the focus this year, along with the movement, the state machine, the movement state machine, that we're going to recreate Overwatch in there. And this might add on top of it to create the multiplayer aspect of Overwatch as well, which, you know, would be boring if it wasn't multiplayer. So if you enjoyed this, please make sure you help me out with the channel, leave a like, watch the video, and subscribe, of course. And that motivates me to keep on going and keep that information free and, you know, share it with you. So that's gonna be it for today. Next episode of this little WebGL and multiplayer series, we're gonna be speaking about and actually implementing a way to identify every single player in a different manner. And we're also going to be making this a little bit more friendly, so we're going to have only one build, and in that one build you'll be able to decide if you're a server or a client at first. So we can launch the same build multiple times, and on one of them we click server, and on the other one we click client, with also the ability to go off and on, so to disconnect if you're a client, and also to put the server offline if you are a server, then back up again, just so we can actually play around with this a little bit more without this whole weird testing loop that we've been doing. So again, thank you so much for watching, share this around, and that's it. I'll see you guys in the next one. Cheers.